Welcome to the new lesson of the course. In the previous lesson, we have seen how activation function is useful in the neural network. Most of the real life problems contain non-linearity, and it is very difficult job to identify patterns and expressing those patterns in a linear form. Activation function will be helpful to build non-linearity in the equations. Now in this video, let us see different types of activation functions. We all know the working of step function. It is also one of the basic type of activation function. This function we don't use much. Right here you can see mathematical and graphical behavior of the step function. By looking into the step function, we can say positive values will be mapped to 1 and negative values will be mapped to 0. The data is mapped to 0 or 1. This function is only useful for binary classification and we may suffer misclassification of data. To avoid misclassification, we can use sigmoid function. Sigmoid function will cover range from 0 to 1. This function is also called as a logit function. Values more than 0.5 are mapped to 1 and values less than 0.5 are mapped to 0. Function we can use for binary as well as for multi-classification problems. Threshold activation function is the extension of the sigmoid function. Mathematical and graphical representation is shown here. You can observe values are mapped between -1 to 1. This function is also called as a hyperbolic tangent and we can use for both binary and multi-classification problems. But based on the research, I would recommend use sigmoid in the output layer, and for all other places try to use hyperbolic tangent function. But during backpropagation, derivative of function is considered. Derivative of sigmoid will map the function between 0 to 0.25 and derivative of tanh function will map the function to 0 to 1. This will lead to vanishing partial derivative of loss function with weight, and function will take time for converging to global minima. This problem we can resolve by using rectified linear unit function. Over here you can see mathematical and graphical representation of the function. ReLU function will map negative values to 0 and other values to exactly same values. If we consider derivative, for positive values derivative would be 1 and for negative values derivative would be 0. If we are getting derivative as in 1 during backpropagation, we will not face vanishing problem. But if we get 0 as a derivative, that will make dead neuron. This problem we can solve by using Leakey-ReLU function. Leakey-ReLU does not vanish the negative values, it just lowers the negative part. Over here you can see graphical and mathematical representation of Leakey-ReLU function. But what will happen if network is deep and most of the weights have negative values? This will again bring to vanishing problem. Exponential linear unit is another variant of ReLU function. LU represents curve for negative values. LU contains exponential terms and derivative of exponential terms will take time for solving problems. So we can conclude LU is computationally expensive. Right here we can see mathematical and graphical approach of LU function. Like all the ReLU versions, the LU function's derivative of x values greater than 0 is 1. The derivative however would be a multiplied by e raised to x for x less than 0 values. Parametric ReLU will work as a ReLU or also will work as a Leakey-ReLU. Right here we can see mathematical and graphical approach of the parametric ReLU function. For negative values, if alpha is small value, then it will work as a Leakey-ReLU, and if alpha is 0, then it will work as a normal ReLU. In this function, alpha is called as a learning parameter. The next activation function is swish or self-gated function. This function was inspired by the use of sigmoid function. Right here we can see mathematical and graphical representation of swish function. We use swish function for more than 40 layers and mostly it is useful for making LSTM model. We have already seen sigmoid function is not preferred for multi-classification problems. Instead of making sigmoid function, we can use softmax function to solve multi-classification problem. This is all about activation functions that we use to bring non-linearity in the network. This will end our video. In the next lesson, we are going to see weights initialization techniques and optimizers we use while making deep learning model. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing.